Okay, so what you have to keep in mind when you're talking about temperature is every reaction is endothermic or exothermic. If we labeled the reaction as endothermic, we're talking about the forward reaction. So when we label it endothermic or exothermic, we're talking in terms when we give delta H positive is given for the forward reaction, and the forward reaction is what's endothermic. So then the reverse reaction has to be exothermic. Okay, you with me on that? If energy goes in for the forward reaction, then when you reverse it, that energy has to come back out. Because remember our little, let me open up some space here. Remember when we draw the enthalpy diagram? This is a diagram that explains everything. So on this one, my products have more energy. So going forward, it's energy in or it's endothermic. So then when I go backwards, now these are my reactants and these are my products. Now my reverse reaction is exothermic. So any reversible reaction is endothermic one direction and it's exothermic the other direction. So what does endothermic mean? Endothermic means that heat increases collisions. Heat helps the reaction happen. Exothermic means heat hinders the reaction. If you're trying to freeze ice, heat's a bad thing. It doesn't help you freeze ice. If you're trying to melt ice, heat's a good thing. So if you're taking water from solid to liquid, that's an endothermic reaction. But the reverse reaction, taking it from liquid to solid, that's exothermic. You're trying to get rid of it. So when you think about endothermic and exothermic, we think of it as heat being a product or reactant. That's because when it's endothermic, heat has to go in and heat helps the reaction, helps the reactants. Okay, so with an endothermic, if the forward reaction is endothermic, heat is a reactant because it increases okay, so that's why we think of it. Okay, so when you're thinking of heat as a product or a reactant, that's why we're thinking of it, because heat going in makes the reactants collide more, but on the reverse reaction then, it decreases the product collisions. So on an endothermic reaction, increasing temperature helps the forward reaction, but not the reverse. Decreasing temp helps the reverse reaction. So for exothermic, heat is being released. So for more product, you need to get rid of heat or decrease temperature. So now you can think of heat as a product that you want to remove. So decrease temperature helps product more, and an increase in temperature I shouldn't say it like that. So decrease in temperature helps product collide less. It's like removing a product. And an increase in temperature is like adding product and the product collides more or shifts left, which we rarely are looking to shift a reactant left. We're always looking to shift it right. We're always coming at it from that angle.